Okay, so the next question here, question 8, page 232. Go to your text. Let me read the question. When a 12-volt battery, so let's just start reading here. V is equal to 12 volt is the potential difference. Is connected across an unknown resistance. So unknown resistance is R, is the unknown resistance that we have to calculate, I think. Unknown resistance. There is a current of 2.5 milliampere in the circuit. So current means I. 2.5 milliampere. So we need to change this to the SI unit. Now 1 ampere is equal to 1000 milliampere. Okay, we remember that 1 ampere is equal to 1000 milliampere. So we have to change to SI unit is not milliampere but ampere. So changing from milliampere to ampere means smaller unit to bigger. So we have to divide 2.5 divided by this 1000. Then milliampere will disappear and ampere. So divide means decimal move to the left. So let us count 1, starting from here, 2, 3 places, 1, 2, 3. So this is the current in SI unit. Okay, so everything has to be in SI unit, right? So here we have to find the question value of the resistor. That means unknown resistance. So since by Ohm's law, we know the famous Ohm's law equation, V is equal to I into R. So we need to find R, so that will be V divided by I. I will go down. So V is here, 12 volt divided by I is 0.0025 ampere. That's the value of R. So that will be, let us remove this decimal to make it easy for us. So that is 12 divided by 0.0025, and SI unit of resistance is ohms. In other words, volt by ampere is ohms. So let's just change it directly to the base unit of resistance, which is ohms. So let us now remove this decimal 1, 2, 3, 4, because it's easier always to deal without decimal in the denominator especially. So 1, 2, 3, 4 means 4 zeros, 2, 3, 4. Up also 1, 2, 3, 4 zeros. Then this decimal will get removed. That also adds 4 zeros here, 1, 2, 3, 4. Multiplied, divided by here 1, 2, 3, 4. It will move to the right side of 25. So 25. This much ohms is equal to resistance. So let us cancel this. 5 5s are 25. 2s are 10. 2 in hand. 5 4s are 20. 2 3. So 1 2 3. 5 4s are 20. 4 in hand. 5 8s are 40. 00. So this is going to be 4800 ohms is the value of the resistance. So this is I think textbook has given this in the kilo ohms. So if you want to change here, we know that 1 kilo, word kilo means 1000, is equal to 1000 ohms. 1 kilo ohms is equal to 1000 ohms. Since we know 1 kilo ohms is equal to 1000 ohms, so you divide this one, changing small to big means, small to big, yes, divide by 1000. Then this ohm will change to kilo ohms, not kilowatts, sorry, kilo ohms. So that will be 1 2 0 cancel, 1 more 0 means decimal move here between 4 and 8, 4.8 kilo ohms if you want to give in the textbook style, kilo ohms. Resistance is 4.8 kilo ohms or 4800 ohms. If the question did not say find in kilo ohms, you can end your answer here even in the exam. Then number 9, but textbook answer has been given in kilo ohms. I'm just showing it. Last one is question number 9, page 232. Oh, sorry, this is not 9, okay, this is 8. The one we've done just now. Now we'll go to 9. Okay, so let's do slowly. So please remember the one we've done just now is 8. We're now going to do 9. Let's go and read the question. Question number 9. Go about it slowly. A battery 9 volts. So let's just write down here. Battery 9 volt means this is the voltage. This is the voltage. We can also say like that, which basically means potential difference only. Now, in series with resistors like this, how much current will flow? So here, let Rs be the total resistance of the what are they of the resistors. Look into your text and tell me what are connected in series. 0.2 ohms, 0.3 ohms, I think 0.4 and 0.5. 0.4 ohms, 0.5 ohms, and 12 ohms. So 1, 2, 3, 4, 5 resistors are in series. Very clearly the question says in series. Means one after another. Okay, so since they're in series, the formula will be, we know for series is Rs is equal to first one plus second one, etc. For parallel, it is 1 by Rp is equal to 1 by first one plus 1 by second one. Since it is series, we have to use the first formula. So Rs will be the first one plus second one plus third one plus fourth one plus fifth one, like this. So let us add the above. 0.2, 0.3, 4, 0.5, and 12. So 12 means 12.0. We need to know that decimal should be on the same line. So all plus, that means we have to add 5, 9, 10, 11, 12, 13, 14. 1 in hand plus 1, 3. So this is going to be 13.4 ohms is the total of all these 5 resistors put together. I'll go back to question. And the question is saying, this is the last question, how much current? So how much current means I only question mark. The current that is flowing, we have to find out. How much current flow through the 12 ohm resistors. So this is the current flow through the 12 ohm resistor. Let's just first find out the total current. This one, let's just hold on 1 minute. This is the total current. We have to put total current. Then we can deal with the specific one in the end. Now, since by Ohm's law, or using Ohm's law, write it down. Slowly, you know that V is equal to I into R. V equal to I into R. This is the famous Ohm's law. Here V is okay, I is okay. R we are using specifically S, so RS. So let's just put. So we need to rearrange this because they are asking us I. That will be V by RS will shift means to the left means go down. So we can continue. I equal to V here is 9 volts divided by RS. Here we found out to be 13.4 ohms. We know the volt by ohms SI unit of current is ampere. So 9 divided by 13.4 ampere. And to remove this decimal, one place, so 1 0 up and down. I'm going to get here 9 into 1090 by no more decimal, this much ampere. Right, so let us cancel this. So 2 6s are 12, 1 in hand, 2 7s are 14, 2 4s are 8, 1 in hand, 2 5s are 10. So 45 by 67. So let us divide that. 45 divided by 67. 0 point, because 45 is less than 67, then 1 0 will come here, then 67 3 2s are 6, 3 6 are, oh sorry, that'll be, let's try with 6 6 2s are 12, 6 6 are 36. Go one more. Oh sorry, this is 67, sorry. 7 6 are 42, 40. So that is the one. If you try one more to just check, 7 49, 7 4 are 28, 29 30, 132, or 67, sorry, 67, 7 7 are 49, 7 6 are 42, 43, 44, 45, 46. 469 is too much, so 6 will go. That is 42, 6 is 36, 402. Then here 8 and here 4 0. Then 7 will go, I think. 7 7 are 49, 6 are 42, 43, 44, 45, 46. So 469, 10 minus 9 1, 7 minus 6 1, 0. Then 1, because 2 will be too much, so you can stop there. 0.671 ampere, which is approximately 0.67. Third place is less than 5, so this much. Now we have to write this. We know this, we learned in our previous class some classes ago that since in series we have explained this before also. In series, the same current flows through same current flows throughout the circuit. You can specify this a little bit. There is throughout the circuit, that is all the resistors. In other words, same current will flow through all the resistors if they are in series. Because, what is the reason? Because there is no alternative path. Okay, there is no alternative path. So your final answer will be, therefore current through the 12 ohm single resistor will also be the same. That is I equal to 0.67 ampere. That's your answer. Now to explain this little bit before we end the class, you look here now. This meaning here, you see, if you connect in series, then from the battery current is coming, plus minus. Current always flows from positive to negative. First one, second one, third one, let us say, like this. Then you see, let us say this is 10 ampere. Then all that 10 ampere will flow through this same, because there's only one path. So 12 ohm here, 2 ohm, 3 ohm. In series means the current that has originated, the total current will flow through all the resistors if they're in series, because there is no additional path. There is only one path or road. But the same one here, you connect this one, R1, R2, R3 in parallel. The difference is this. So I'm just explaining it once more so that we're clear about it. So here, first one, let us say this one. Second one, let us say this one. And the third one, let us say this one. R1, R2 and R3. Parallel means they are connected between the same 2 points A and B. R1 is connected between A and B points. R2 also between A and B points. R3 also between A and B points. That's called parallel, connected between the same 2 points. Connected between different points. R1 between AB, R2 between BC, different points, and R3 between CD. All the three resistors are connected at different points, the series. Between same 2 points like this is parallel. Now this is the battery, let us say. Means positive, negative, longer line. Now current I comes out here. So I comes here, which is let us say 10 ampere. Then some will flow through here. Think about this 5 ampere, let us say. Here some will go 3 ampere. 10 total, so 5 plus 3, 8 plus 2 will go here then. So that is now total is 10 still, nothing is lost. Okay, in parallel, there is 3 paths, one different path. So some current will flow through the first resistor, some will go to second and third, because there is additional paths. But here there is only one path, therefore the current flow through series is same. I hope you got it. Okay.